Okay, this recording is basically going to help us understand how to solve quadratic equations. One of the biggest things about quadratic equations is that there's lots of ways to solve them. So you'll notice the equation down here at the bottom would be a really good example of the fact that there's lots of ways to solve quadratics. 0 equals 4x squared minus 9 is a really good equation showing us lots of possible methods. Again, we've got three good methods to solve with: factoring, square roots, and the quadratic formula. This is a really good example, again, of all three of those methods. The question is, which method would we prefer? Which one's going to save us the most time? So let's look at this method solved, or this equation solved in all three methods, and then we can maybe come up with some good ideas as to when to use factoring, when to use square roots, and when do we have to use that quadratic formula. So taking a look at our equation, again, we've got it solved all three ways here. This is one very unique equation that actually solves fairly easily by all three methods. But let's see where the advantages are within those methods. So taking a look over here at the square roots on the left, well, why was this easy to solve with square roots? The biggest thing I notice is we're really solving for just x. And since at the very beginning of the equation there was really only one x there, I didn't see an x over here with the -9, I didn't see an x on the other side of the equation. Well, it was easy enough just to say, let's add 9, let's divide by 4, right, in that next step, and then very simply we'll take the square root on both sides, not forgetting to say plus or minus, and we'll end up with that, again, plus or minus 3 halves, right, square root of 9 over the square root of 4. Well, that was pretty quick and pretty easy. And usually when you're solving by square roots, it kind of will be that case. Factoring is also a fairly quick method. Now, it looks like a lot of steps, but really let's take a look at it. We had a perfect square in the beginning, 4x squared. We also had a perfect square on the end, that 9. And if you remember our perfect square patterns, the difference of squares, right, that minus sign in between, is a great chance to split that up. 4x squared would be 2x times 2x. -9 is -3 times +3. And we can call that 2x minus 3 and 2x plus 3, again getting us that -9, as well as a -6 and a +6. If we foiled that back together, we'd have a 0 in the middle, right? We wouldn't have that middle term. Well, if we can factor it apart into these two quantities, well, now if we're factored and equal to 0, we can split that up, right? This equation and this equation, which very simply means then let's add 3 to both sides on this equation. Let's subtract 3 from both sides on this one. And again, divide everything by 2, and we'll still end up with, notice, right, plus or minus 3 over 2. And again, the same thing works with the quadratic formula. Quadratic formula, we first needed to identify, well, a would have been the number in front of x squared, so 4x squared. B is the number in between. Well, wait a minute, there is no middle term, right? We noticed that's why we could use that difference of squares to factor. B was 0. And C, the constant, would have been -9. But because we were equal to 0, we could identify, again, A, B, and C because we're in standard form equal to 0. Then we plugged all of our numbers in, and the fact that B was 0 is what made this a little bit easier, right? This 0 here and this 0 there sort of disappear. And if we multiply out the discriminant, notice we end up with 144. The square root of 144 being 12. And again, 12 divided by 8, still getting that plus or minus 3 halves. Again, all three methods are very good methods. But notice the quadratic formula takes a little bit more writing, a little bit more simplifying. We got to be comfortable with our square roots and our fractions. Factoring is great when it works. The difference of squares is a great time to factor. However, factoring sometimes is more difficult than it's worth. And square roots is great, but again, we can't have a middle term. We can only have a single variable. So that's where that one comes into play. So a couple of good ideas when we're choosing a method to solve. If standard and b is equal to 0, if you're in standard form and b is equal to 0, such as an equation like our 4x squared, right, minus 9 equal to 0. Notice again, b equal to 0. There was no middle term, right? No middle. Well, if that's the case, it's a great time to solve by square roots, as we saw. Now, you can also do that if there's only one variable. What if we had an equation like x minus 3 squared? Let's just say plus 7 equals 10. Well, there, again, it's not standard form, but notice how we only have one x. That's a great time to solve by square roots. And we'll maybe look at one of those here in just a minute. Now, if it's standard, b does not equal 0. What if we have a middle term? What if we have something more like, x squared plus 5x plus 6, or 3x squared plus 7x minus 12, right, equal to 0. What if we're in standard form? We can get it into standard form, we're equal to 0, but we have a middle term. Well, now I can't use square roots. But the next thing I would look at is, and again, both of these methods, factoring and the quadratic formula, if we're equal to 0 and in standard form, both of those methods are great ideas. Now, again, I wouldn't waste a lot of time factoring. I would look at my equation very quickly. If the numbers factor easily, so let's say we saw the 3, the 7, and the negative 12, and we just knew what they factored into. Or if a equals 1, again, that's really, really helpful, then it's a great time to factor. So if I was looking at, again, this equation up here, right? Well, what multiplies to 6 and adds to 5? I would say 3 and 2. Boom. I can factor that very quickly and simply. On the other hand, that 3 in front, the 12 behind, remember that 3 in front especially was when factoring got very difficult. So we had to factor by grouping or some other larger method. That would be a great time to, again, use the quadratic formula. So let's take a look at 3 different examples and decide, again, what would be our best method. I'm not saying we couldn't use other methods. In fact, the quadratic formula can always be used, but again, it's not always the shortest method. So glancing at this equation over here at the left, the first thing that I notice in that equation is I only have one variable. I only have one x. So I would say let's go ahead and solve by square roots. If we just do some simple algebra, I can add 5 to both sides. Okay. And we'll end up with, oops, sorry there. Didn't mean to do that. We're going to add that 5 again to both sides, which gives us 5 equals 3x plus 6 squared. Then we can divide by 3 on both sides. So 5/3 equals x plus 6 squared. Now here's where it might get a little messy, but at least it's a fairly simple step. If I take the square root, I can cancel off that squared, right? So take the square root, and don't forget to say plus or minus the square root of 5/3 equals x plus 6. And now if I subtract 6, but notice one of those is under the root, so I'm just going to say negative 6 plus or minus the square root of 5/3 equals x. Then I could go on to find those decimals and figure out what those answers would come out to. Again, the exact value is pretty much what we already wrote. But again, if we wanted to find those decimal values, we can definitely do that just by typing in negative 6 plus the square root of 5/3. As I said, negative 6 plus the square root of 5/3. There we go. And we will get a negative 4.709. Or we can type in the square root, negative 6 minus the square root of 5/3, giving us a negative 7.291. And those would be our 2 good answers. Now let's take a look at this one in the middle and see if we can't maybe quicken up the process a little bit. Again, I wouldn't have wanted to do quadratic formula on that first equation because I would have had to FOIL out x plus 6 squared and distribute and subtract. then start into the quadratic formula. That's just a lot of work. The same thing goes for this middle equation. Well, taking a look at it, well, I can't use square roots because, again, remember we've got that -3 in the middle. But I also kind of don't want to use quadratic formula. Notice how we've got a 1x squared? This is a great chance to, at least for a second, think about factoring. What would multiply to -10 that adds to -3? Well, things that multiply to -10 would be things like 5 and 2. And hey, if 5 and 2 are 3 apart, if that were a -5 plus 2, doesn't that add to -3? Well, that means that x minus 5 could be 0, or x plus 2 could be 0. So x equals 5 or -2, and hey, we've got our answer. That's way faster than using that quadratic formula. Well, in this last equation, the first thing I notice is I've got an x squared and I've got an x. So I'm thinking square roots is out. The next thing I would take a look at is that we aren't equal to 0. For either of the other two methods, factoring or quadratic formula, the first thing we want to do, subtract x here, subtract x there, is get ourselves equal to 0. And now, because I noticed that 2 in front, I'm thinking factoring might be a little bit difficult. Factoring may be pretty tricky. So I'm going to go directly to the quadratic formula. I'm not going to waste a lot of time trying to factor. If it doesn't come to me right away, I'm moving on. Which means now I can say -b, well, notice in the middle, that's a -1x. So negative of -1 would be 1, plus or minus the square root of. -1 squared is 1, minus 4 times a times c, all over 2a, so 2 times 2. And now it's just a matter of simplifying. Again, this one takes a little bit of extra work. I know that 1 minus 8 times -7, 4 times 2 times -7 is going to be a -56, but make that a positive, right? 1 minus the negative. So we're going to get a positive 57 here over 4. And now I've just got to type those in separately. 1 plus the square root of 57 over 4, since square root of 57 is not a nice number. And 1 minus the square root is 57 over 4. And if I type those in very carefully, I will get, well, the positive side comes out to a 2.137, and the negative comes out to a negative 1.637. And those would be my two answers. So again, you can see where all three methods are very helpful in different situations. Solving by square roots is fairly straightforward, sometimes a little bit messy, but the steps are fairly simple, right? We just do things like adding or dividing, and then take that square root as soon as we need to. Don't forget that plus or minus, and then keep on going. Factoring is very quick when it works really quickly. You know, we could just split them, solve them, and then keep on going, right? Split, solve, factor, split, and solve. But again, when neither method really seems to work that well, the quadratic formula always works. We just need to get into standard form, equal to 0, and we can work that out. Well, I hope that helped you solving equations. I hope that helped you decide which method you want to use. Good luck on your homework, and have a great day.